You will do exactly the same thing as the train test. It's basically a copy paste of your previous code, but just some changes you have to make. And then you'll be all set. Okay, so the change we're gonna make is we will have X scale transform fed in into the split. Y will remain the same, no changes at all. Right, so let me just make sure X train X test, Y train Y test, X train is transformed. This guys go in there. X train Y blah blah blah. We start here. I think we are good to go. X test is coming in from there. Yeah. Keeping my fingers crossed because I put everything in one go over here. So let's see where is the cursor. So cursor is already fitting right now. That might take some time.
Mine is done, sir.
Nice. On the PC data?
On the PCA?
No, I'm saying the PCA transform data, right?
Yes, PCA. Yes.
Okay, fair enough. We'll wait for others to catch up. We're just running it on the PCA data now. I think you've already done it, right? Yeah. Hmm? Estimator? This one? Ah, okay. Ten, 100,000. Up fit transform. Ooh, why is it giving me red? That's running. Let's see. It's running. So not sure what is the red here. But it's not giving me the cursor where exactly it is right now. Hmm? Yeah, but it's not populating results. Busy. Some internet connection maybe. Yeah, I'll give it a minute. Not sure what happened. Let me just close again. Interrupt execution. Scale transform 5, 5. Correct. That's correct. X-train, Y-train. Okay. X-train. X-train, Y-train. X-train, Y-train बराबर है. Next test, Y test. Correct. That's fine. Fitting on X-train, Y-train. Okay. Yeah, the code is correct. Let's see. I don't know what is the error that I got, but let's just confirm one more time. It's done. Yeah. Finally. So time-wise, I don't think I have gained anything. It doesn't look like. $556, and earlier it was 700 something, so slightly less. But you can see even with the less number of variables, I mean, the model performance is not looking that bad. I mean, of course, it has dipped a little bit, but not as bad. Now, if you want to see what are the most important features, you can do that, but I think it will be not necessarily meaningful. So principal component 1 and 2, they are the most important. 1, 2, 3, 4, 5. Same thing. So you can go with principal 2 components only, and then you can still get a good result. Not much difference. Anything else, folks, on this topic? Are you done? We are good, right? Folks online, any challenges on this? So you could see, like, how end-to-end deploy a PCA. Time slightly we gained, but not, no, I'm good. So slightly we gained, but not much. And you can see, like, I mean, but the big thing is, I mean, even with the reduced number of features, the performance is not looking different at all. I mean, maybe different. I wouldn't say not at all, but yeah. Correct. When? Yeah. So for the bigger data, you'll see more difference coming in. Correct. Yeah. For the bigger data, the difference will be much more clear. All good? Shall we move on to the next topic? Folks, anyone online? Any questions, thoughts from anyone? So this is the entire end-to-end walkthrough. In case you want to deploy a PCA, run the model, do the interpretation, all of that can be done in this forum, like we just gone through, right? So that's the main takeaway from there. Now we'll go to very different topic altogether, right? And I'll give you I'll give you 10 minutes to go through this. This is article number 38. And if you click on that article, this will say, please read this first, right? So go ahead and read that first. We'll begin with our discussion on these Excel files and what they really mean and all of that, right? So very important to get the grounding on it. So article number 38, and then it says, please read this article first. Click on it. And then this is what, 3:20, 3:30 will kick off the conversation. Now I will go ahead. MBA, Market Basket Analysis. Actual execution is not very difficult. The concept is more difficult, right? And then I will give you the assignment for today that you can start working on. Shall we? Who would like to talk about what we have understood? Okay, good enough. Yeah. Anything anyone else in the class would like to add? Yeah, absolutely. Great. Anyone else in the class? No? You've heard? Mm-hmm. Yeah, correct. So I think all of you did good in terms of summarizing that. Online folks, anything from your side on this topic that you would like to highlight before I cover some of the main points? Okay. So the MBA is market basket analysis, right? And it's basically what we call as association. You're trying to associate things together, right? And there are many, many examples. If you go to Amazon, they'll say people who bought this also bought this, right? Or items bought together. Or in LinkedIn, you will say people who view this profile will also view this profile, or they will make a recommendation that you should connect to this person, right? All of those are, nothing but something similar of that nature, right? Any other new examples that you've seen? Netflix, everywhere. Because you watched this movie, that's why I'm recommending this movie to you, right? Or something of that nature. Yeah. Yeah, frequently bought together. All of those things are there. So it's basically nothing but what we call as the strategy for upselling, upselling and cross-selling. What is the difference between them? Any ideas? You want to try? Nish? No? Upselling is, let's say you're going to buy a mobile phone which is less than 15K. You went into shop for this, right? But then they will start to show you things like, I mean, you know, these phones are available. You may consider. They will say you may consider, right? You may consider like, and they will say 25K phone or 30K phone. I mean, of course, they're not gonna pitch like more than 2 lakh rupees of phone. That will be absurd, right? I mean, if you are in the market and you're looking for that, so it has to be related to each other. So that's the upselling, that you went in to buy certain things. You went to buy one shirt, and they said, sir, if you buy two shirts, you'll get 50% off, right? Something like that. So that's upselling. What is cross selling? You go to buy a shirt. This is trouser will also go very well. So shirt will be worn with a formal shirt will be worn with a trouser, right? Or if you go to buy a mobile phone, you will get the glass or the cover and all of those things. I mean, sometimes it's very obvious, sometimes it's not very obvious, right? When you have millions of products like an online retailer, it's very, very difficult, right? So let's go to Amazon. And search for mixer grinder. Mixer grinder. Let's say we select one. So what do you think they will be pitching to buy along with this, with a mixer grinder? Anything for mobile? It's what? What? Blender. Okay. Let's see. Juicer. Okay. Let's see. So I think for the phone, it's very easy. Phone. I mean, no brainer. Why do I need to build this engine, right? I mean, I can just tell you like I'm going to buy these accessories, right? Let's see what they are saying. Frequently bought together, or if there is any recommendation coming at all. So there is this one coming in, right? So hot water thing, right? So let's see what is this. That's exactly what. So this is what the engine is doing, because it's not intuitive. Like why the customers who bought this mixer grinder will buy the hot water thing, but because they have formed this trend that people who buy this, they also buy this. That's why they're making the recommendation to you. They cannot just randomly give you any product, because that can backfire also. That why are you telling me to buy this? I mean, I'm not even thinking about it, right? Now let's see what they're recommending for this. What do you think will be the recommendation here? Let's see.
Mugs.
Right? So they're saying, I mean, people who buy this, I mean, now imagine you're coming in to buy a hot water kettle, and they're saying buy a juicer or a mixer grinder along with that. Because that's what people are really going in. They're setting up their kitchen or whatever might be happening. I'm not sure. I'm not sure what is the linkages, but I mean, they have formed trends where these things are related to each other. So that's how this market basket analysis really comes in, right? When you're looking at the movies and all of that, what do you think? How do they make the recommendations? Yeah, it could be anything. It could be like like I mean, you watched a couple of horror movies, then they say, okay, this person really likes horror, right? I mean, they'll suggest watch one more, right, and so on and so forth. And let's say you start to watch a romantic movie, and you gave like I mean, they will ask feedback, and oh, I really loved it, right? So they will keep on pushing the romantic movies, right? So that's the explicit liking or disliking. But how many customers do the explicit liking, disliking? Very few customers. I mean, I don't do. I don't rate anything at all. Yeah, correct. I don't rate at all. I mean, like either one of them, right? So if I don't rate, then how would they make the recommendation? Any ideas?
Based
That's
on
implicit.
genus
So
and
if you watched a 3 hour movie in 15 minutes, that means you was kya crap hai, right? And you just kept on forwarding and all of that, and right, yeah. But if you like really enjoyed the movie and you're watching scene by scene, you may have rewinded certain places and all of those things. I mean, that becomes your implicit liking or disliking, right? So you don't have to be explicit all the time. You can be implicit, and based on that, they will make the connection. That if you like this movie, who was the hero? What was the genre? How were the song qualities? Was it this sort of movie? Like many different attributes, right? And based on those attributes, they will make that connection for you. Everything is being recorded. What do you think? If you rewinded that song in Pushpa, they will know how many times you watched that song. Even the YouTube is the same way. Like how many videos you've watched, how many times you have watched, where exactly you have paused. Yeah, where you paused on that video, everything is being noted down. Right. So that's how they actually make the recommendation, right? But we're not there. I mean, so that is much more complex recommendation engine. So we'll talk about more simplistic recommendation engine, right? And we will build on certain things over there. But you get the idea of what is the rationale behind that. So is this a supervised or unsupervised, or none of them? How many for supervised? Raise your hand. Only one supervised? You are also supervised, no? Unsupervised. Achha. Only you are supervised? Tanmay? So, two supervised, okay. Why? You giving what? Okay. Why did you say unsupervised? Tejashni, you have to do the tie breaking.
Now I'm confused.
You heard both judgments, or I mean both justification, not judgments, but both. You tell me what it. You said neither one of them. I'll think about something else. No, seriously, what do you think it is?
I kind of agree with Manju that I initially also thought the same way, so I still feel it's unsupervised.
Folks online, what is it? Supervised, unsupervised, none of the above.
Unsupervised, I'll go with.
Bhavna says unsupervised. Why, Bhavna?
Because there is no target to predict, right?
Okay, no target to predict, Bhavna says. How many of you buy that argument from Bhavna? No target to predict. Not convinced? Convinced or not convinced? Convinced. Predict.
So can I take a side too, sir?
Yeah, please.
So
Zara?
I think it's unsupervised. No, sir. Rujul, sir.
Ruzul, sorry, yeah. Yeah, unsupervised, Ruzul?
Yes, sir.
Why?
So because supervised is more like a particular thing, and unsupervised is mostly association and what goes together and those type.
All right, okay. How many people agree with Ruzul or disagree? Tanmoy disagrees, right? Completely disagree. So he's just not disagreeing, he's completely disagreeing. Like, I mean, there's no room for negotiation at all. Unsupervised, Rashmi says unsupervised. So, I mean, we have more votes for unsupervised. But the correct answer is it is unsupervised algorithm, right? Because there is no Y that you are actually labeling against. You're doing the similarity, you're doing the groupings, you're doing things of that nature. So there's no target variable over here. So that's the correct reason that Bhavna and Manjunath, I mean, some of the other folks, I mean, Tejashni and others pointed out. So that's the correct reason, right? Okay, let's continue. So this is the first unsupervised learning algorithm besides the PCA. PCA is also unsupervised. So if you go in this file, you'll have to download this data, retaildata.csv. Let's go ahead and, I don't have the access. Which account I have signed in? Let's see. For you also, no? No. So I have to see where exactly this is. I may be. Okay, let me add another profile. I may be on a different account here. No, that's a different one. This is something that I made up. Rojul, can you go back to the previous machine learning and see if you can find this file?
Yes, sir.
It's called retail data underscore, sorry, retail underscore data dot CSV. And in
Yes,
the
sir.
meantime, I'll try to sign up with a different account.
Yes, I'll just check it.
Okay, thank you. Oh, okay. All right, let me see. Okay, so I'm gonna send you while Rojul is trying to dig it up. I'll send you by following another method. Yeah. So I sent you one file. Let me send you one more file example. So I'm sending both files on the, oh, I already had that example file here. I didn't know that. Okay. So both files should be there with you. Let me know once you have it. Okay, once you have the file, folks, you can go ahead and open it up and we'll begin some of the discussion using first file, which is the example in the team. Okay. So we talked about some of the metrics and I think you tried to explain, but we'll do that in the example itself, in the Excel file. So let me know once everybody has the Excel file open, which is called example. Excel file example. You don't have it in the Teams? Online detail we'll do later on, but just the example file is not there in the Teams. You have? Example is also there, no? Example one. Just refresh. Just refresh, it'll be there. And we're gonna begin with a baby example so that you understand what these concepts are, and then we'll jump into Python for you to do. You have it? Example. Somebody's unmuted, I believe, in this class. Sure. Why don't you take maybe 1 minute? I'll just get some water in the meantime. Familiarize yourself with this file, and then we'll keep over.
Hey guys, hold on now. Ganesh and Pete. Hold your process. आज जल्दी की break बटन दबाएं. फिर अभी lunch के लिए. Clear कर. First item consider, second item output ಆಗುತ್ತೆ. See, they are related. No, you didn't get it.
Shall we start? So how many transactions we have in this data? We have only 5 transactions, right? And how many products are there? 5 products: milk, bread, butter, beer, diapers. When it says 1, that means that product was bought in that transaction, right? So in transaction 1, what were the items which were bought? Milk and bread. In transaction 2, correct. Transaction 3, and then you get the flow, right? So what is support in plain English? It's the frequency basically, for lack of
Assistance, help.
Sorry,
Assistance, help.
persistence,
Assistance and help.
assistance. Okay, yeah. I mean, it's more like, I mean, how many times that item really happens, right? So you can see in terms of the language, support of score product A is nothing but the count of product A divided by the total number of transaction. So it's basically nothing but a frequency, like, or from the total transactions, how many transactions had this item. Out of the total transactions, how many items had this item? Let's do one. Support for milk. How many total transactions we have? 2. So support for milk will be 2 transactions out of total of 5 transactions had milk. So support for milk is 40%. So that means 40% of the total transactions have milk. Correct? Support for bread is how much? 3 by 5, right? Total transactions where the bread is bought is 3 out of 5. So that's 60%. So 60% of the transactions have bread. This is tricky. What is the support for combined item, butter and bread? So where they were both bought together, how many items are there? Only one. Which is the one? Bread and butter bought together. Bread and butter, this one, right? So that's 1 by 5, which is 20%. Now it's for you to tell what is the support for butter? 2 by 5, 40%, right? 2 by 5, yeah. Support for milk, bread and butter?
20%.
Where all 3 of them were bought together. Milk, bread and butter, all 3 together. Where is it at? This one.
60%. That
1
will
by
be
5, which is
60%.
20%. Support for beer and diaper? Yeah. So now what is support? Who can tell me? Based on we just went through. What is the significance of this? Okay. But why should we worry about it? I mean, why should we know how frequently this is bought? Why should we worry? Correct. So that's the main reason. Like, I mean, if you're looking at an online retailer, they may have millions and billions of products, right? So they cannot start making a recommendation for a random product for you, right? I mean, so that's like a long tail of product, right? So they have to look at, I mean, is there a significant volume for this? Is there a significant number of people who buy this? And then I only should make the recommendation for you, right? Imagine that, huh? Huh. Hmm. Right. Correct. I hope this makes sense, everyone, that we have to focus on the volume products, right? We're not focusing on every single product out there. So we will see, you know, when we're building rules, I mean, there should be some significant volume of that, right? So that's the support. Now let's talk about the confidence. And this is where the name of this algorithm really comes in, which is a priori, right? Or the rules that we'll be building will be called the antecedent and consequent in Python, right? Antecedent is an event which happens before. Consequent is the event which happens afterwards of that. So if that event is, you know, shaped in a particular way, consequent will be different, right? So let me give you an example. Let's say right now West Indies and India, they are playing T20 games, right? I mean, there was a game yesterday. At the beginning of the game, let's say, what was the probability of India winning versus the West Indies winning? So I think Tanmoy likes cricket. He just, Achha, achha. So at the beginning of the game, let's say the probability of India winning was 70 and probability of West Indies winning was 30%. Now, if India had made, let's say, 250 runs, let's say everybody played their out of their skin, right? And they made 250 runs. What will be the probability of West Indies winning then? Will it be 30% or significantly lower? Lower, right? So that's the concept of conditional probability. And conditional probability is nothing but like if one event has happened, what is the probability other event will be happening, right? So if it is raining, let's say in Hosur, what is the probability it's going to rain in Bangalore also, right? I mean, higher than the random, right? So because maybe the storm system is coming in from east and whatever, right? I mean, that happens to be the case, right? So that's the concept of conditional probability, right? So here we're trying to figure out if one particular item is bought, what is the probability that the next item will be bought? And if they have a very high probability, I would like to put them together, right? So then I can make a recommendation that you're heavily likely to buy this, right? So that's the confidence metric that we're looking at. So left hand side uh, towards right hand side, right? Or you can say the antecedent and consequent, which is nothing but the probability of right hand side happening given the left hand side has already happened, right? Which is nothing but the uh, the um, the what do we call that in probability terms? Not the union, but the intersection of that, right? So both events happening together. Or you can say this is nothing but in the lingo of the support of right hand side and left hand side divided by the support of left hand side in terms of the support definition that we're looking at. So this confidence is nothing but support for both right hand side and left hand side event to be happening together divided by the support of left hand side happening. Let's do one. So what is the probability that milk will be bought given that bread and butter has already been bought is how we're going to read that, right? So what is the probability that the right hand side will be happening? What is the right hand side? Milk. What is the left hand side? What happened? Gone? Acha, acha. Okay, folks online, can you hear me?
Yes, sir, I'm able to hear you.
Yes,
Yes.
sir, we
Yeah.
can hear.
Yes, sir.
Okay, I cannot hear you because I think the setting is. Now say it again one more time, whether you can hear me.
Yes, sir, we can hear.
Okay, great. Okay, so let's go on, right? So I think we tried to rescue and we went into a different direction, right? So let's do the confidence, which is first of all, left hand side is bread and butter, right hand side is milk. So is it? No, it's here.
We are not able to see.
Okay, hold on. Now,
Yes, sir, can see.
oh, awesome. So the confidence we're trying to estimate is what is the probability that somebody will buy milk given that they've already bought bread and butter. How will that be transformed into? Just look into this definition. So what is the support of right hand side and left hand side combined together? So how many instances where milk, bread and butter, all three were bought together? What is the support of that? We just did that in the previous one. 20%, right? So which is basically your this numerator 1/5, which is a 20%, right? What is the support of left hand side? What is the left hand side? Bread and butter. So what is support for bread and butter? 1/5, right? So the confidence for this transaction that milk will be bought is 100%. So given that somebody has already bought bread and butter, there is a 100% probability that they will buy milk, given this baby data, right? Because there is only one transaction where all three of them happen together, but that's the concept of the statistical analysis, right? Or I mean, this is not statistical, but the probability, right? Who can give me this confidence? What is the numerator and denominator for diaper and beer? 1/5 by 1/5. So what is this? So you have to compute this number basically. Support for right hand side and left hand side combined together. So diaper and beer together, only one transaction, which is 1/5, divided by the support for left hand side, which is only diaper, and again 1/5. So 100% confidence, right? So if somebody buys a diaper, they will 100% likely buy a beer as well. Now, who can tell me the support for beer given milk? Beer given milk. The line number 23. Beer given milk. What is the probability that beer will be bought given that milk has been bought?
0%.
0. Okay. Let's see. So 0/5 divided by 2/5. Why 0? Because there's no transaction where milk and beer have been bought together. No transaction. Support for right hand, remember this is the holy grail of that. Support for right hand side and left hand side combined together, right? So there's no such transaction where both right hand side and left hand side happen. So that is the case why it's 0, right? What is the confidence for butter given milk? Confidence for butter given milk. So what is the probability somebody will buy butter given that they've already bought milk? 50%? So this turns out to be 1/5 divided by 2/5, which is 50%. So 50% likely that they will buy, right? Last one. Who can explain this? $33. How? What is the support for bread and butter together? 1/5. What is the support for bread only? 3/5. So that's 1/3. So 33% confidence. Any questions on the support and confidence before we go to the last one, which is slightly more? This one, yeah. This is the definition. So how do you read that? So the confidence is what is the probability right hand side will be happening given the left hand side has already happened. going back to the West Indies example, that what is the probability India winning, that given West Indies is already made two, I mean the other way, right? So that's that one, which is in the writing for the conditional probability is what is the probability right hand side will happen given the vertical line is given that left hand side has already happened. And then in terms of the probability, which is nothing but the intersection of both right hand side and left hand side probability wise divided by the probability of left hand side. In terms of the support that can be transferred into support for both right hand side and left hand side happening together divided by the left hand side. If you get confused with all the journey from left to right, just focus on the right, the extreme right, which is support for both of the sides divided by the support for the left hand side. This formula right here. Confidence. Correct. This is what we're using to compute these metrics. Shall we do one more? Let me pick another file. This is not the right data. Retail. I'm looking for the retail one. Okay. I'm making up certain data, so just allow me a moment. Now let's see who can give me this answer. So just focus on this data right here. So I want to estimate what is the confidence for, I'm just going to specify the left hand side and right hand side, right? So because everything has bread and everything has butter, then I want to estimate, oops, not this line, but vertical line. Sorry, the other way around. I mean, actually, let me just put it this way, like, I mean, just make it easy for you because I'm just going to follow that definition, which is, who can tell me what is going to be this number? So it's going to be support for bread, butter, and the bread, butter, and egg. Okay, let's go with this. Divided by support for bread and butter, right? So basically what we're trying to estimate over here, Tanmoy and Tejashni, is that given bread and butter has been bought, what is the probability that egg will be bought, right? You follow the left hand side, right hand side combination. So left hand side is given bread and butter has been bought. What is the probability that right hand side will be bought, which is the egg, right? So now I'm going to show you that definition. So just a minute. Like this, right? So left hand side is this, right hand side is this. So basically the support for right hand side and left hand side divided by support for left hand side. So what is the probability that egg will be bought, given bread and butter has been bought. So this is the left hand side. Support for left hand side and right hand side. So what is left hand side? This, and egg is the right hand side. Correct? Now tell me what this number will be.
%57%.
57%. Tell me the numerator, like in the first the numerator and then the denominator.
Numerator is 4 by 7.
Numerator is 4 by 7. Denominator?
Divided by 7 by 7. That is 1.
7 by 7. Is that correct? So what are we saying? That 4 transactions out of the total where all 3 items have been bought: bread, butter, and egg. Bread, butter, of course, is given. So how many egg? We have 4, which is 4 by 7. That's correct. And how many transactions where bread and butter is there? 100%. So that's correct. So the confidence is 57%. What is the confidence for dairy? Who can tell? Dairy. So it will be exactly the same thing, but I'm just gonna replace the egg with the dairy. Correct. Sorry. Dairy. Which will be numerator. How many transactions where dairy was bought along with this? So that's 3 by 7. 3 by 7 divided by 7 by 7. Yeah, you will see that. I mean, when we do that in Python, you don't have to do by hand. I'm just telling you this mental math you should be aware of. So that's this number. That's this number, right? So it's basically the, like, because these are the only 2 items remaining in this, so they are complementary. I mean, they're adding up to 100%. But if you have many more, then this could be like, very, very fractional numbers that you're looking at. So that's the concept. So I'll close this file and go back to the baby example 1. So any questions now, Tejashwini, on the support and confidence, or are you good? Okay. All right. Okay. Anyone who'd like to explain to Tejashwini how we measure confidence? Tanmoya, you want to try?
Or shall I do explaining it?
Let's see how people. Once you get to the entropy, then you can always make the connection with respect to precision and the recall, and then we are good shape. So tell me, what is left side, what is right side? Left side is whatever is written on the left. No, left side is whatever is written on the left. The other left. Go to the left. Wait. So then you should the other left. No, you have 2 lefts. The other left. So what is left here? You tell me. Bread butter is on the left or egg milk? Row number 21. What is on the left side? Bread butter is on the left side, right? Milk is on the right side.
What we are trying to predict is,
Given left hand side has already happened, what is the probability right hand side will happen?
okay, for a moment, we take out left and right, so I will try to use the same name. So given that I have bought bread and butter already, what is the probability of me buying milk also?
There you go.
So for that, how we are calculating is we are trying to find out how many times bread, butter, milk all were bought. And then we will divide it only by how many times the bread and butter was bought.
Exactly. That's it. So you're just not saying the left hand side, right hand side, you're saying everything else. That's exactly what it is, right? So you're saying that like this is this. Now, how can we conclude that they first bought the bread and butter and then they bought the milk? Why not the other way? That they bought the milk and that they want to buy the bread and butter? Probability will be estimated for all of them actually. When you're building the rules, it doesn't choose what is the left hand side, what is the right hand side. They will say if they bought milk, what is the probability they will buy the bread and butter? If they bought bread and butter, that what is the probability they will buy every possible combination. Correct. That's why we define those rules. That I don't want to show those rules which are not meaningful. We'll take a look in terms of defining those things. Tejashwini, one more for you. What is the line number 24? What is the left? What is the right? Line number 24. What is on the left?
Butter is right.
Butter is right. You're right. Correct. Butter is right.
Milk is left.
Milk is left. Yeah.
We will calculate for how many times milk and butter together were bought.
That's correct. Only the left hand side.
Okay, milk and butter together,
Yes.
and then divided only with
This one. Left hand side.
milk.
Correct. Left hand side is milk. That's correct. Yeah. You're right. You're getting a hang of it. I say you got it.
Yeah. It's just that.
Anyone online who's confused on confidence and support? But what is the significance of support? What is the significance of confidence?
So now maybe
Why do we need to have both?
support will let us know which product happens to be the most bought out of my transactions.
Correct.
Whereas confidence will only show the relatable items that I buy whenever I make a transaction.
Correct. That's correct. So support may be like, you're looking at pure frequency, but there is no interrelationship between the product. Confidence is the what you're telling, like, who is related to who and what is the confidence that you're getting. Now I'm going to make it even more confusing and we will have look at the left. Anyone who volunteers to explain the left to me? I don't know why.
That is also not supporting.
Lift,
Lift, not left.
lift.
Commonality and both the products because the ratio both of A and union of both are divided by the individual product, multiplication of the individual product. So, for example, if I were to buy one product, we are taking the example of two products. Now, what is the commonality or the relation of the both the products clubbed together divided by their individual buying option?
Okay, close enough. Yeah, finish. Seems like you're very excited to tell. Tell me.
I got happy because I got left right.
Good. So,
Okay, let me give it a try.
Hmm.
So if list is something like, let's say for example, if I have to buy product A and product B individually, against if I would have bought them together based on their association. So if I were to buy two products only based on the association of it, divided by just buying them independently. That is,
You're close enough, yeah. So lift is a measure of how are they related to each other. So if they are completely independent, let's say, what is the probability you will buy um, a diaper to the probability you will buy a broom? So diaper and broom, let's assume they are not related at all, right? So then the lift will be 1. They're completely independent because the support of A union B, if you expand that, that will be two independent events happening together. When two independent events are happening together, their probability of happening both together is nothing but the probability of first happening times the probability of second happening. So this is slightly more probability oriented concepts, right? So then this will be exactly similar to the denominator, and then that will equal to 1. If the events are completely independent from each other, lift is 1. If two events are interrelated in a positive way, then support of A union B will be a bigger number than the support of A and B multiplied together. Because if they are interrelated, so go back to the example of Hosur. What is the probability that rain will be happening in Bangalore? Given that probability is happening in Hosur, that will be more than the probability of Hosur times probability of Bangalore, because they're interrelated. So probability will be bigger number. Now, what is the probability it will be raining in Dallas while it is raining in Bangalore? They're completely independent ecosystem and all of that. So it will be probability of rain in Dallas times probability of rain in Bangalore. That's the probability. Independent events, right? The third case situation is what cannibalization, right? Which is, if you have bought one product, the probability of other event to be happening is very, very low. So let's say if it has been raining since morning for 5 hours, what is the probability it is going to rain in the 6th hour as well? Or what is the probability sun will come out in the 6th hour? So it will be lower. So they are cannibalizing. If one event is happening, the other event may not be happening with that same force, right? So let's say if you just bought a refrigerator from LG, shall I make a recommendation to you buy a refrigerator from Tata immediately? That will be purely stupid recommendation, right? Because if I've already bought a refrigerator, the probability of the other event happening to be will be significantly lower than independently. So that's the concept of the lift. So if two events are cannibalizing each other, lift will be less than 1. If two events are independent, lift will be equal to 1. If two events are supporting each other, lift will be more than 1. Yeah, so let's say, I mean, like for anything, like you have bought a mixer juicer, for example, right? And then we were looking at, the water heater. So in that case, the lift will be more than 1. Why? Because if both events happening independently, if they are completely independent, then what is the probability the customer will be buying this as well as this? Will be probability of this happening times this happening if they're totally independent. However, if they're dependent, then that probability will be higher because they are interrelated, right? So that is the concept. The numerator will go higher than the denominator. Denominator is nothing but the probability that both events are completely independent. Like I gave the example that what is the probability of rain to be happening in Dallas and at the same time in Bangalore. They're both independent, completely independent, right? So that is that probability times this probability, which is a multiplication of the probability, that will be even smaller number. Probability is always less than or equal to 1. So when you multiply two probabilities, the net probability is lower if they are independent, right? So let's say the probability of rain happening in Dallas today is 0.2 or 20%. Probability of rain happening in Bangalore is 10%. What is the probability to be raining in both places? 0.02, 2% only. So 20% probability in Bangalore, 10% probability in, I'm saying 20% probability in Dallas, 10% probability in Bangalore. Both happening together will be only 2% if they are independent. If they are not independent, that will be higher number, is what the concept is. I mean, you can go to some of the probability rules. I'm just simplifying that. But the interpretation is lift of more than 1 signifies a favorable impact on one product to another product. Lift of 1 says no interrelationship at all. right? And lift less than 1 says you should not make that recommendation. They're actually eating into each other. That's the concept in terms of the actual application. I'll take a pause here again. We'll do the example. We'll do the example. Yeah. We'll do that. And then I'm gonna give you the case as well. But I hope these three things are clear. Support is pure frequency. Confidence is if this has happened, what is the probability the next event is gonna happen? Lift is are they favorable or independent or unfavorable to each other? Let's say I'm in market to buy a digital watch. I just bought something, or I just put something in my cart from, let's say, boat. What is the probability now I'm gonna go and put a noise watch as well in my system? Very, very low, right? Because they cannibalize, right? If a person buys this, they will not buy the other product. So that's the concept of the lift. Make sense? Up to a certain extent, right? So we will do the example and then you will be more clear. Okay, so we will work with this file, folks. So let's make sure that you go to Python now, and we will switch gears and do this in a code fashion, right? So I'm just gonna explain you, but I will not type it over here. So you can do that yourself. I'll just explain you what is happening over here and then give you time to make sure that you do it, right? So all this is pretty regular thing for you, but you have to make sure that you install these packages. If you're working in the Jupyter, you'll have to install this, which is conda install ML extension of the ML. Conda install, this is again the same thing, which is the ML extent. And then after we have done this, we are grabbing from the ML extent frequent patterns. And we are importing algorithm called a priori. A priori is nothing but like, conditional probability. And then we are importing association rules. So just understand the code first and then you will do it on your own. I'll run the code myself as well if you want me to. Then we're going to import this file, which is the retail data.csv, the file that I've shared with you. What is happening over here? Block column 1 till end indexing. So we are grabbing all the rows, which is this column, and column starting at 1 till end. Yeah. So it will give you this data. Then we are doing pandas get dummies. Anyone has used this one? Pandas get dummies. First class you've done it. Okay, so what it does is basically it will create, so it will look into the product one and look at how many levels do we have. And for each of the level, it will go horizontal. And like, product one bread, 1 0, product one fruits, 1 0, whether this particular transaction was having the bread or not, right? So in this case, bread was there, so you can say 1 is marked. But there was no fruit, so fruit is 0, juice is 0, nachos is 0, right? So these are the 4 different products that we have: bread, fruits, juice, nachos. And similarly, it will go on to this one, right? So you can see that I have reformatted the data. And then what we're going over here is we are saying a priori on this data, which is BA10. Minimum support is 0.05. What does it mean? Yeah. So it's gonna give you those rules or recommendations, but I'm saying for each of those recommendations, make sure that at least there is a 5% volume. So if you tell me that somebody who has bought fruit, they will buy, I don't know, let's say if somebody has bought fruit, they will buy butter. So unless those happens at least 5% of the time, do not give that rule to me, right? So that's the minimum criteria that I've specified. Then what we're going to do is we will form the association rules from this data. Metric is lift and minimum threshold is 1. So we are saying only give me those rules where lift is 1. So I don't want any cannibalization in my product, right? So I want a lift to be positive. Positive in a way, they have like either independent or they will be helping each other, right? So then based on that, we will see the rules. And these are the rules which it has generated for you. So you were confused with the left-hand side and right-hand side. Here, left is antecedent and right is consequent, right? So like, what happened prior? So antecedent and consequent. So it says, I didn't say, you give me this rule it said, okay, I'm coming out and telling you this rule that somebody who has bought butter, left hand side, what is the probability that they will buy bread, right? So it says that there is a 87% confidence that this may happen. How many transactions are there like this? 21% transactions are there where somebody who has bought bread, somebody who has bought butter, they have bought bread. 21% transactions are there. Maybe same, maybe different. I mean, in this case, so you can say this is different number, right? So it says bread and butter. So it gives you immediately the next rule. This is 61%. It depends on what becomes numerator, what becomes denominator. Yeah. Right. So from that point of view. But how we can beat the first two, second line? First and second line. They are different rules. So the first, so let's say you're checking out. You're going to big basket. You checked out butter. Which action did you take first? Butter or bread? It's serial mein kar rahe ho na? Like, I mean, what is the first one that you did? I mean, you cannot put both of them together, right? No, I mean, it's up to that. Okay, just complete. Okay, then he will one by one. I don't know how did they.
He's not done shopping. Don't ask him.
No, pretend you are going to online place.
Okay.
You put something first in your cart. You cannot put two items together, right?
Okay.
I mean, even you're trying to put together, but still there will be difference, right? I mean, what did you put first? So that's the left hand side. Antecedent. Consequent. What consequence? What is consequence? Consequence meaning something has happened. Then consequence is going to come in. No, consequence cannot be first and then something else will happen.
Something has happened by right.
Then as a consequence of that, what is going to happen?
Consequence is by right.
Consequence is right hand side.
Something happening first is left hand side. So
Antecedent.
first, then right. Okay,
This makes sense. For example, somebody who makes butter, basically,
Will eat with something, no? Yeah.
it can be jam or butter also.
Yeah. But don't try to make sense of this data because I made up this data. So I'll tell you the actual data. Yeah. But you're right. I mean, so that could be the difference. I hope this part is clear. So it depends on your action. What did you put first in your cart? Then as a result of that, I'm going to make the recommendation. Same thing happens in Walmart and other places if you go to US. So they will print out the coupons for the next purchase, right? So let's say you bought diaper. They will say, what is the probability this person is going to buy, let's say, baby formula, the baby milk. Based on that, they will generate the coupon because if they randomly start to give the coupon to the bachelors and all that, they'll waste so much coupon, right? So if you've already bought something, then they will say this person is likely to buy that.
Right.
And then they will make the purchase. Right? So that's the intelligence which comes in there, right? And the other way also, right? I mean, if you've already bought the baby formula, what is the probability you'll be buying a diaper? Very high. If somebody is drinking the formula, they will be wearing the diaper as well. Right? So it's basically from that point of view. Right? So I'm just giving like some like things. I mean, so they're not the same thing. Left hand side, right hand side. I mean, you flip them. It's not likely that they will have the same probability. So then we get these, and what are these antecedent support and consequent support? Just interpretation from this. Yeah. So antecedent, which one is antecedent here? It's labeled over here. Butter. So that means how many transactions were there when butter was bought? 24.65% transactions where butter was bought alone. Or I mean, maybe in combination with something else, but butter was there. Consequent support? Bread. 35% transactions have bread in it. This support? 0.2145. When the both bread and butter were there together. That's the support for that. Yeah. Correct. That's exactly right. So they are the same. But confidence is different because the right hand side, left hand side can be different. Right? So the confidence is different. Lift. How do I interpret lift? 2.49. Is it a good thing or bad thing?
Good thing.
Good thing, right? Yeah, because they're favorable. Leverage, I will not necessarily comment on. I mean, because I have already confused you enough. So we don't use leverage that much or conviction for that matter, right? So just stick with support, confidence, and lift. All right. And then we can do the sorting by support. You can see which are the transactions which have the highest support. You can do the sorting by the confidence. You can see which are the transactions which have the highest confidence. So for example, over here, who would like to interpret this one? This number, confidence one. Tell me in plain English, what does it mean? That I have a confidence of 1.
So that means there is a very good union of all these products going together. And if I have to put actions, are more likely to buy all of them. Confidence of them, either bought together or individually.
So even if I bought butter and egg, I must also buy it.
Correct. So if somebody has already bought butter and egg, there's a 100% likelihood they will buy bread. Right? Everybody follows this?
Yes.
So this is, if somebody has already bought butter and egg, then they will 100% likely buy the bread. Right? Similarly, I mean, again, I have made up this data, so don't worry about it. If somebody has bought salsa and egg, 100% likely they will buy nachos. I don't know about the egg, but salsa you can won't directly lick like that, right? I mean, you have to have something, chips or nachos or whatever, right? So you eat with this, right? So that combination is there. So that's the confidence. Support, let's interpret this one. What does it mean? 0.57. Oh, sorry. Let's look at the highest support. Highest support is this one. Egg and jam. What does it mean? 2570. Correct. So there are 25.7% transactions where both egg and jam together were bought. Clear? So it's simple. It's not that difficult to follow, right? So, and you will see those things. So here comes your next assignment. So I mean, after you do this, I mean, I'll help you out with this, right? But then there's a slightly bigger data. I have also put the code for you over here, right? So and then you can sort, by the way, I mean, just like a data frame sorting, right? You can build your own rules, right? So your business says, I want something which has a support of at least 20%, the confidence of this, and lift more than 2. Only give me those rules. So these are the finalized rules for you. I can only make the recommendation like this. If something else happens, I'm not making a recommendation, right? But the moment I have a butter bot, I can make the recommendation with for the bread because I have a very good support, very good confidence, and the lift is more than this. So I can, have my own filters in terms of doing that, right? So I'll let you play with this data. But once you've done this, this is the assignment you're going to work on. And this is coming in from Kaggle again. And this is slightly biggish data. Yeah. So this is what 5.5 lakhs transactions, right? So, but you don't have to worry about all of them. So there are many, many countries, right? You can grab just one country that you want to work with. It's your choice. I mean, but grab something which is meaty, right? So either US, UK, just figure out some significant number of transactions are there, right? So I can tell you which have the major transactions. So here, just allow me a moment. So you can grab United Kingdom has good number of transactions, UK, but that's too many actually. I don't know, some European Union, I think combination. You can grab France or Germany, right? US is not there. I think it's all EU only. Is it? Yeah, but that's not meaningful actually. Spain is there, right? So you can grab any of those countries, or you can grab multiple countries. I don't worry about that, right? But this data is not there in the same format, right? So this data is looking different. So I'm going to tell you how we will format that. So here you can see this is the actual data coming in from the retailer once it opens up. Right. So here what you have is basically the invoice number, right? Like a transaction number, right? Stock code that you can ignore. Description, what was the item bought? How many items were bought together? When did they buy this? What was the unit price? What is the customer ID? Which country they bought it from? Right. So it's a proper working data that you can expect from the retail. Right. So what you're going to do over here is some cleaning up on the data, which is again there on my blog. So don't do anything different over here. Yeah. So this is what we're going to do. Right. So the first thing is we will import this data like we have done. And this is also there on the UCI machine learning. You can grab from there as well. So this is the shape of the data. You can see there are 38 unique countries. I grabbed Italy. You can grab anything you want to. Then we're going to do a pivot table on this data that we've shortlisted for one country and index by the invoice number. So invoice number becomes like this. Columns are the descriptions of the products become this. And values are the quantity, right? So how many times they bought. And then we are also doing fill value is 0. So if something is not populated, we're going to fill 0. So for example, in this particular invoice, this particular item was bought 4 times. However, if I don't have anything, that means that item wasn't bought. So I'm going to do the fill value as 0. Everybody's clear? Right? So I'm just going to fill the missing value with the 0 right there. Then I don't really care whether it was bought 4 times or 5 times. I just care about whether it was bought at all or not. Right? So that's what I'm going to do next in this code. It's a simple code, which is if x is less than 0, return 0. Less than or equal to 0, return 0. If x is greater than or more than 1, return 1. I don't care whether 4 items were bought or 10 items were bought. Just as long as something was bought, it's 1. So 0, 1 binary I'm doing, right? And then once you do that, you will apply that on basically your data, and then you're going to go forward, build the rules. So you'll set basically your basket data, minimum support, all of that, and then you can see some rules are coming in, and these are the rules which came in from there. After I applied certain other filters, right? Minimum threshold for the metric lift is 1. So it says if ABC treasure book was bought, ABC treasure book box some box was bought. Then we're looking at what should be the recommendation that a red retrospect Charlotte bag should be there or not, right? So there are 7% transactions where this item was bought, 5% transaction where this item was bought, 5.5% transaction where both were bought together, and there's a 75% probability that if this is bought, then this will be bought as well. And the lift is a healthy looking 13.75. So there's a lot of complementariness in these two products, right? And these are the rules that we create. It's very simple, straightforward. Yeah. Tell me. Get going then. It's all there in the blog. MLXing. If you're doing in the Jupyter, if you're doing in the Colab, then you're good to go. So I'm just going to execute on my that data. Yeah. Just grab it from the blog. I mean, it's the same thing, article number 38. So in Google Colab, you don't need to install anything. It's already done. But if you're doing in the Jupyter, you have to install it. So then upload your retail file. It's fairly straightforward once you install the package. It doesn't take very long time. So you can see my rules are generated over here. And then we have certain rules like this. If lift is more than 1, confidence is more than 80%, support is more than 20%, only show me those rules. And these are the rules that come up. Online. No, this is retail. This is the baby data set. Retail XLS. Retail underscore data. If you want, you can directly build that one. All there in the blog 38, article 38 on the blog. It's basically more advanced ML packages like the a priori and some of these things, which are not necessarily by default loaded in the ML environment. It's very different from the scalar. So this is some of the other packages that we're looking at. And if you want what all is a possibility, what you can do is just put ML extend, put dot, and then hopefully it should pop up some of the things which are there. You can see these are the sort of, some of the things which are coming up, right? I mean, no, you don't have to install. That will come naturally. But if you're doing in the Jupyter, then you can install.
Online.
First, work with the retail file. There are three Excel files essentially. One is example. The other one is the retail underscore data. First, work with that. Just follow the same thing that we have in the blog, article number 30, in the same model. And then work with the online. So then the teams. Okay.
for
Let me know when the first example is done. First is done. and then you can take the next one as a homework. You can work on it. Exam. At least the first one we should try to finish today. How do we make sure that we are giving good?
Yeah.
Sort of subjective. That's why it's in the class of the unsupervised learning, right? So I mean, there's no 100% way of telling like a regression model or classification model how good or bad you are. Yeah. So you have to evaluate vis-a-vis the business impact, do some testing, figure out what really makes sense. Is it working out there or not? Things like that. Then anyone online who needs help with the example one? And anyone has any questions based on what we've discussed so far? Tanmay, how are you doing? All good? Then, any questions? Manjuna? So let's talk about what we're going to cover next time also. Let's see what all is pending. So I'm just going to send it on the chat window. What are the topics we will cover next time around? That's one. Yeah. Anything. Yeah. I mean, if you have the words, which combination of the words can be, n-gram sort of thing, you can use it. Yeah. Let's see what all is pending. That's it. So I think we can cover the k-means, H2O, and hierarchical clustering next time around. Three topics. And then we'll see how much time remains. We can take it from there. Do we have output from everyone? Manjuna, you have got it. Folks online, do we have the output or are you still working on it? You have the output? Okay.
I'm still working on it.
All right. Sure. We can take some more time. Any questions, thoughts, anything which is not clear based on what you have seen so far today from anyone? Sorry? Interview questions? People don't normally ask theoretical questions, right? So they'll say, walk me through some of the work you've done. So even if you haven't worked in a live production environment, you would have done some project work, let's say, capstone project and stuff. So I'll say, walk me through, right? So whatever you've done. So you say, I've chosen to do, NLP and sentiment analysis on this topic, right? So then basically, based on what you are sharing, more questions will come out on similar lines. It's mostly about the whys. So if you just start asking two questions, why, And so what? Right? So why did you choose this technique? Then you say, oh, because I thought this will be good. Why? Right? So just 5 whys. So right. So you'll get the hang of the questions which are gonna come in, right? And then you say, okay, I found out that I built this Twitter sentiment analysis. So I'll say, so what? What do I do with this? Like, what business problem you're able to solve? How does it connect to some of the things that you're actually working on? It's same thing. I mean, it's. I mean, very few people will say, show me how this algorithm really works. Walk me through like all the different things that you do. Some people may ask you. It's not like, but at least if you say, okay, these are the projects I've worked on, then you will do. Or there'll be coding round. Coding round is very common. So for most of the interviews, you will begin with the coding round only. Even for data science or research science or applied science or artificial intelligence, I mean, you must fetch your data first. So can you do the SQL query, for example? How many of you do SQL query on a regular basis? You do it? Okay. Ranesh? No? How about you? Achha. And yours is not the tech background, right? Okay. So that's not a problem. I mean, that can be picked up. Correct. SQL is very easy. Select from where. So those are the sort of things that you should prepare for. But I think, I mean, just understanding the things why you're doing all of that is very important.
We are doing kind of MBA kind of. So, but industry
I don't think industry really separates between an MBA and MS, to be honest, right? So if you're going in, you're gonna do the same thing, right? So from your point of view, you just should be good at uh, technical concepts and all of those things, right? So all of that. And I think nothing like, showcasing your own work. People who have been selected earlier on, I mean, they have all been able to showcase a live working example based on ML. Nothing like it. Did I talk about this carpenter example or no? I think I would have very beginning. No, I would have, right? I mean, I always begin carpenter, yeah. No, we haven't. Not in your batch. So if you were to hire a carpenter, the story I share, right? I mean, and that story is very relevant for all of you. If you were to hire a carpenter, one carpenter says that I've gotten the degree from the best carpentry school in this world. The other one says, I have the best carpentry tools with me that you can ever imagine. Latest and the greatest tools are with me. The third carpenter says that this is what my work looks like. Which one are you going to hire? The same thing for you. If you say, I have got a degree from Reva or Princeton, or you say, I know logistic regression, XGBoost, and you just start to say random things randomly, right? Or you say, okay, I have built certain things, let me walk you through. So you're going to incline more for the third bucket, which is what is your work? Show me your portfolio. It's as simple as that. The conversation changes. Will there be any day when you will be knowing everything there is to know in the data science? Never. Right? So that is not going to come. Will you have to wait for 5 years before you feel comfortable in doing that? Probably not. It's just basically you have to play on your strength and you have to take the conversation in your direction. Yeah. Most of the people go through like this only. That you have one good example, two good examples to show for, and then you can take it forward from there. But these things are not really rocket science or difficult. Rocket science itself is not very difficult, but I'm saying they're not very difficult, right? I mean, anybody can do it. So, and there are umpteen number of examples where people have done it, right? But you just need to, plan and do things accordingly. Participate in hackathon challenges, right? Showcase your work on LinkedIn. Talk to your network. Talk to within your company if there is an opportunity where you can leverage your domain expertise to start contributing in the ML area. All of those things. What were you doing, Tejaswini, earlier on? Yeah, it's related only, no?
That is where I started to like instead of just being there overthinking and bothering, let me also it's kind of probably very interesting. So they were like all this confidence. So every meeting is confidence bias, what is the bias and all. So whether the prediction is right or not for
Yeah.
promotion.
There you go. So same sort of thing you should think about, right? I mean, nobody's going to ask you, hey, Tanmay, go build 5 models today, right? So it's more about like overseeing the work of the others, right? Being knowledgeable enough to figure out what is going on in the flow, not being left out of the conversation for the lack of the knowledge, right? But mostly going to be at the managerial level, right? Where the expectation is not that much that you're going to do hands-on. But it doesn't mean also that you just keep on blabbering, things which may not be relevant for the discussion. So you need to know what is going on, right? And your biggest critiques will not be your peer or superior. Your biggest critiques will be the team members that you work with. If they know that you don't know anything, then they're gonna shit all over the place because this is not gonna work, right? So you have to work with like who's below you and whether they see and look up to you or not in your knowledge. That's all. Anyways, the peers that you'll be talking to, they don't know anything about this, right? So if you even say something wrong, they won't be able to detect. Seriously.
How do we interact? How do we with respect
Yeah.
to the skill, because now they are
Yeah. Yeah. The easiest will be within your own company, in my view. You have a lot of equity within the company. I hope, everybody has equity in the company, but you still have a lot of equity in the branding in the company, right? So you have to leverage that. Rather than you going like a fresher in a brand new company with 15 plus years of experience, that is a harder battle for you to fight. It's not saying that it may not happen, but easier is within your company, get involved with the ML related projects. First, as I just want to mentor the juniors, right? So, for example, let's say there are a couple of data scientists working. You say, no, I don't worry. I just want to like learn more about what is happening there, and I'm gonna leverage some of my extra bandwidth to contribute. As a POC, you can start.
But if you're not easy, nobody will accept you. Basically, everyone will say no. Better start with something.
That's how it is. So if you start applying in job portals and stuff like that, may not happen right away. Build that experience, show that profile, and then do it. You can build it in your company, or you can build it over here by picking up the projects and working on some of these things.
I did code and
Yeah, yeah, yeah. I don't code myself in Amazon, so I don't need to. I mean, I have a team to do it, right? But I do it here and all of that, right? So, but you're expected to be knowing certain things and all of that, right? So, at least to be understanding what is happening, shape up the analytical plan, provide them the direction. If they are doing BAs, then identify the BAs. This model will not work, or problem is not identified, and all of that. So you have to challenge them. Ask the right set of questions. That is the expectation at your level. I mean, nobody's going to expect you to build like 5 models. All you're doing this is to show that. And if I don't do this teaching, I mean, I would be like completely rusty because my job doesn't require me to be hands-on. I mean, I would like to do it, but I mean, it doesn't necessarily require me to be doing coding myself because I'm already there in so many meetings or document reviews, this, that. I mean, I don't have time to go and was बैठ के model बनाते हैं वहाँ पे, right? So that won't work. Okay, any questions on this particular initiative or project? Good. So then let's take it as an assignment that we'll work on the other one as well and then come back and then do a joint presentation on this and the previous one, which is pending. So we'll have 2 presentations next time. One is on this rules thing that we talked about. The other one is on the random forest and with the PCA combined together to see whether you can get the output for that data, the loan data. And next time we will talk about clustering and H2O, which will make your job a little bit easier to build some of the more complex algorithms and how we get the output from them. So that's the plan for next time. Folks online, any questions before we wrap up? I know we're almost on 5:30 mark. 2 presentations. One is the rules. Random forest we haven't done, na? Random forest combined with PCA on the loan data. If you're not able to execute, see whether you can reduce the dimensions first on the PCA and then do the random forest and then see whether you're able to get the output. On that data. No, you did it on the retail, the made up data. Now there is actual data that you have to build this example on. Some more data maneuvering is required there. Online, that Italy, UK I was showing you. Clear? So we'll begin with those 2 presentations. I hope, I mean, that's enough time for you to work on it and make sure everything is ready. Okay, that's it, folks. Thank you. Take care. No, I've sent actually on the team. I have sent on the team. Let's see. If you go to files, next will be the, I mean, next class will be the presentation. So that's the submission time. Sorry.